One thing that can be very tricky with Python operations is item assignment. Sometimes we are making a copy of that memory into an entirely new memory, and sometimes we might just be pointing to the same memory. So to demonstrate that, I'm gonna start with a simple case. So let's say C equals 10. And then after I run this cell, this line, C will have the value of 10 stored in the memory. And then what I can do is say that D is equals C. And then after D has been assigned to be C, I can say increment C by 1 unit, and then we can just print. Let's print C and D. In this case, what I can tell is that, well, we assign 10 to C, and then when I assign C to D, D is using a new memory. It's just a copy of C to that new memory location, and then once I modify C, D remains the same. So at this time, D is equals 10, and then C becomes 11. So at the end of this code, C is 11 and D is 10. So that's quite intuitive. That's probably the expected behavior. But then when we're dealing especially with data containers, such as lists, things get a little bit different. So let's say C is equals to an empty list. So as we saw, lists are defined by square brackets. And now what I'm gonna do is I'm gonna say, okay, so D is equals C, same as in here. And then what I'm gonna do is I'm changing C. So I'm gonna do C append 1. So this should be adding one value to this list, which is equals to 1. And then I'm gonna do D append 1, and then C append 2. So I think for those who are not used to Python, they would think, okay, so I'm adding 1 to the list defined by D, and I'm adding 2 to the list defined by C. But now let's see what is the value of D and the value of C. So let's print C equals C, and then D equals D, and let's see the result. So both C and D have been assigned in both cases. So what is happening here is that C is a data container, like a list. And when I assign C to D, I'm actually making D point to the same memory as C. So as I add data to D, I'm also adding data to C because they are the same thing. They point to the same memory. And then when I assign data to C, I'm also assigning to both C and D because they are the same object. So that's the difference, and that's something you need to be very, very careful within Python. So in order to be safe, what we do recommend every time you're dealing with some data container is to create copies if you do not want this behavior. So the safe way of doing the code above without making C and D be actually the same object is defining C as an empty list, and then when we define D, in the case of a list, we can access the method called copy. So a lot of the objects in Python will have a method called copy that you can use to create a explicit copy of that object. So what this does is that C points to this location, And then D, it's a copy of that location. So they are no longer the same thing. It's just a copy of that. So now if I do the same operation and print C and print D, this is more of the expected behavior, right? So C was empty list, and I appended 2 to C. So now C has 2. And D was a copy of that originally empty list, and then I added 1 to that list, and D becomes 1. So because I created a copy, they are no longer the same object. D is just a copy of C, but they point to different memory.